Hello friends, welcome to Susan and John MathTube. In this topic, we are going to learn something new, and that is rectification. In some books, instead of the word rectification, they use a very casual word, length. Or some people prefer to be more apt and they call it the arc length. Anyway, as usual, let's start with the function y equal to f of x. And I have convinced you so many times functions correspond to graph. And let's imagine this is the graph of the function y equal to f of x between x equal to a and x equal to b. Okay, now for your convenience, I'm going to magnify that graph and I'm going to consider the part between a and b. So I'm using another color. I think you can see the blue color which I'm drawing just above the curve. Okay, so in rectification, what we do is we consider that portion. I think you can see something like this. But I'm going to rectify this bend. I'm going to make it straight. I'm going to hold it straight and I'm going to measure the length. So basically in rectification, what we do is we measure the length of a curve between 2 points in the x-axis, x equal to a and x equal to b. So I hope you understood that part. I'll repeat once more. We have a function y equal to f of x and the corresponding graph. And what I want is, I want the length of this curve, now I am using that red color, between x equal to a and x equal to b. So what I did is I took that part and then I am rectifying, I am correcting the bend in the graph. I am going to hold it straight and I will measure the length. And that is exactly what we do in rectification. Okay. So I hope you understood what is rectification. Now I'll give you a small introduction so that you're familiar with how the formula comes. Anyway, it is not exactly the mathematical proof, but something to convince you. Because once you are convinced with the formula, you may enjoy the subject more. Okay, so look at this. We have a graph of sin x. And I'm sure as bachelor students you're familiar with the graph of sin x, and I'm using degree here, and the maximum value of sin x is 1 and the minimum value is minus 1. So you can see that the curve passes through the origin and it goes in cycles. And you consider any part, you'll be able to see the bend in the graph, especially at this part, you'll be able to see the bend of the graph. There is a maximum bend over here. Okay, anyway, what I did is, in the second picture, which I'm going to show you, I magnified it. It's the same thing, I magnified it a little bit so that you can see the bend clearly. I think you're able to see that bend. Now what I did is, I'm magnifying again. Now I think you're able to see the bend, but look at this. I am considering only a little bit, so let's say this much. Still, I think you're able to see the bend here. So I'm magnifying again. Okay, and this time I can see a bend, but something surprising is happening here. Even if I am considering the same interval where I'm drawing that two lines, the bend has slightly decreased. And it looks kind of like a line. Okay, let's go ahead. I'm magnifying, still I'm magnifying. So now I'm going to consider the two lines. So this time it's almost straight. And if you consider this part, here also you can see that it is almost like a line. Are you able to see that? Here it's almost a line. And I magnified even more. So look at this, you can look at this part. Yeah, it is a line. So I did magnify as much as I can and finally look, it looks perfectly like a line. Remember, it's the same graph. It's the same graph. We started with sin x, right? So it's the same graph. I didn't manipulate it. This is actually the logic behind the formula. Okay, now look at this. Let's go back to our graph y equal to f of x to construct the theory. And let's imagine this is our function graph. And I want you to consider the region between x equal to a and x equal to b. And in between, let's say there is a point. Let's say the point is called x. And of course, the height will be f of x. But this time, I'm not interested in that. But it's kind of like considering 2 points very nearby. Very nearby. And just now I explained, if you, I'll magnify this. Look at this. If you magnify, the curvature will decrease and it will start looking like a line. The more you magnify, I cannot magnify more than this here, but the curvature will decrease and you'll be able to focus on points nearby. Or in other words, what I'm trying to convince you is, if you consider the point x to be made up of a rectangle, because I told you last time, the function will look as if it is creating a line. And if you magnify even more, it might look like this. If you magnify like what you call, let's say literally infinite number of times. Remember, this is our x. This is our x. Look at this. I told you before in the video where we started areas, and I told you that if you keep on magnifying a line, it looks like a rectangle. So this is x and I magnified. It started looking like this with the function over here. And I magnified more and the function looked like this. Let's say I took this part. I think you can see that. It looks almost like that. Okay, anyway, this is x, and in this direction, can you see the right angle triangle? I'm going to call it dx. It's so small, this thickness is dx. And in the y direction, this is also so small, this is dy. And this is the function. This is actually the curve. This is the curve actually. And that I'm going to call it ds, where ds stands for this much length, an elemental length of the curve. And by Pythagoras theorem, ds square is equal to dx the whole square plus dy the whole square. I'll repeat, this is not extremely mathematical or something. It's a simple proof which you can understand. Now I'm going to divide throughout by dx the whole square. So I'm going to end up with ds by dx the whole square is equal to 1 plus dy by dx the whole square. And then I'm going to take the positive square root because I'm avoiding all the negative possibilities without explaining. So you end up something like this. I take this to this side, so we get something like this. That means the elemental length is nothing but root under 1 plus dy by dx the whole square. So what this actually means is, you take any part of the curve and magnified millions and millions of times. And if you call that ds, it is given by this formula. Now you have to understand one thing. If the total length between a and b is s, then s is actually the sum of all these ds. And what is summation in a continuous manner? Integration. That you have to remember, that you have to understand. And if you don't know that properly, please watch the first video in areas or my first video in definite integrals. So remember, integration means continuous summation. So look at this. I'll repeat what I told you once more. If S represents the total length between A and B, then you have to understand this S is made up of ds plus ds plus ds plus ds plus And remember, this is magnified, not, you will never be able to see this ds or anything practically. This is theoretically, it is made up of millions and millions of, mathematically you have to say infinite number of ds. And how do you add infinite number of quantity in a continuous scale? Integration. But just now we found that ds is nothing but, oh, I forgot that dx. So you end up with integral a to b root under 1 plus dy by dx the whole square dx. Oh, that's it, my friends. Okay, now I know some of you don't like this theory part, but basically you should learn the theory behind everything. Whether you're going to by heart it or not is not the important part, but you should always understand there is a logic behind every formula, because that will help you understand mathematics more. Okay, anyway, I'll make it plain simple for the students who are not interested in the theory part. Consider the function y equal to f of x. And let's assume our function corresponds to a graph, something which looks like this. Let's imagine a positive graph. Now suppose we are interested in the length between x equal to a and x equal to b. And let the length be denoted by small s. Then s is given by integral x equal to a to b root under 1 plus dy by dx the whole square dx. So I hope you understood this. So let's do one small problem and wind up this video. Okay, write the first question. Find the length of one arch of the cycloid x is equal to a into t minus sin t and y equal to a into 1 minus cos t. So I have introduced you to this cycloid before also, and the first thing, as always, like in areas, the first thing to do is you make a rough graph. And I told you long back itself, you should be familiar with the equations and the graph. Otherwise, it is difficult to survive in problems related to length, area, volume, etc. Anyway, I know the fact, the parametric value t is equal to 0 here and t is equal to 2 pi. And if you consider the midpoint, at this point t will be equal to pi. And I also know the fact it is a symmetric curve. And then look at this, I want this much length. That means I have to rectify this and hold it in a line and measure it. So the first thing I am going to do is I am going to denote the length by s. So s is given by integral limits root under 1 plus dy by dx the whole square dx. Anyway, I have a little bit advantage because I already know the values of t. I am going to write t is equal to 0 to 2 pi. And that means I have to express everything in terms of the parameter. So immediately I need two things, dy by dx and dx. So look at this, that's not a big deal. It's from your high school calculus. So x equal to a into t minus sin t. And y is equal to a into 1 minus cos t. So this is our cycloid. So dx by dt, that is a into 1 minus cos t, and dy by dt, that is a into 0 minus minus will be plus, and cos, the derivative goes to sine. So dy by dx is, if you want, I'll write this as a formula. It's basically dy by dt upon dx by dt. And that means basically it's by this, and we get sin t by 1 minus cos t. because this a and a will get cancelled. So I want this and I want this so that I can find dx. So dx equal to a into 1 minus cos t dt. Okay, so that's it. Now let's plug in all the values. And s is equal to integral t is equal to 0 to 2 pi root under 1 plus sin square t by 1 minus cos t the whole square, and dx will be replaced with 1 minus cos t dt. I hope you understood that. Instead of dy by dx I am using this, and instead of dx I am using this fact. Now that's it. If you know integration and simplification and a little bit of trigonometry, you'll find it really easy. So let's take LCM. 1 minus cos t the whole square plus sin square t the whole divided by 1 minus cos t the whole square. And we have a into 1 minus cos t waiting outside, and that will be integral t equal to 0 to 2 pi. I am going to split the square root, and the denominator square root and square will cancel each other. So we end up with 1 minus cos t. We have a into 1 minus cos t outside. So this is going to get cancelled. And by the way, what is a minus b the whole square? A square minus 2ab plus b square plus sin square t. Okay, now I am not going to waste your time. Tell me, what is cos square t plus sin square t? Yeah, that is equal to 1. And 1 plus 1 will be 2, and 2 comes outside. So I am going to skip a lot of steps. So we get root under, anyway I'll write this a outside, 2 minus 2 cos t, because this is 1 and 1 plus 1 is 2 and 2 comes common, we get this. By the way, 1 minus cos t can be converted into half angle. So remember this, and if you want you can note this alongside because it will be helpful in solving some other question. Anyway, it's better that you study both the formulae together. So let's carry on. A into integral t equal to 0 to 2 pi. This will be root under 2 times 2 sin square t by 2 dt. And that will be a into, this will come outside the square root. So t equal to 0 to 2 pi. So 2 comes outside and sin t by 2 dt. Now look at this. You saw the graph of the cycloid. And from the graph itself, the property of definite integral is obvious. I already told you, this is t equal to 0, this is t equal to pi, and here we have t equal to 2 pi. Okay, so we are ready for integration, and that will be 2a, and sign the integral is negative, and I am going to write cos t by 2 whole divided by 1 by 2 within the limits t equal to 0 to 2 pi. And that will give me this 1 by 2 will flip and we get minus 4a. Plug in the upper limit, we get cos pi, because 2 pi by 2 will be pi, minus cos 0. Use a calculator, you will get this minus 1, minus 1. So this is the length of one arch of the cycloid. So the length from 0 to 2 pi, that is one arch. This much length is 2a. So that's it, my friends. I hope you understood what is rectification. Rectification means arc length. And we have a very, excellent method using calculus to find the length of arcs. So I'll be back with more problems in rectification tomorrow. So till then, my friends, bye. And don't forget, if you like the video, please share and subscribe.